Hello and welcome back to the brand new series of Science Exploded. Now, today's episode is all about light-emitting diodes. Now, LEDs are the real unsung heroes of the electronics world. They do dozens of different jobs and are found in all kinds of devices. You probably didn't even know about some. For example, you have LEDs in your remote control. You have LEDs on your watch. There are even LED TVs which offer some of the best contrast images around. Now, LEDs are light bulbs basically that fit into an electric circuit. However, they're not bulky, they don't need a filament, and they practically last for nearly ever if looked after correctly. Now, LEDs work using the solar movements of electrons in a semiconductor material, and they last just as long as a standard transistor. Now, a diode is the simplest sort of semiconductor device. Broadly speaking, a semiconductor is a material with varying ability to conduct electricity. Most semiconductors are made up of poor conductors that have impurities added to it. The process of adding these impurities is called doping. Okay, now a semiconductor with extra electrons is called N-type material, since it has extra negatively charged particles. In an N-type material, free electrons move from a negatively charged area to a positively charged area. And a semiconductor with extra gaps for electrons is called P-type material, since it has extra positively charged particles. Now, electrons can jump from one gap to another, moving from a negatively charged area to a positively charged area. Now, a diode comprises of a section of a negatively charged N-type material bonded to a positively charged P-type material. Now, this arrangement conducts electricity in only one direction, which would explain why many diodes only work when the current is passed through them a certain way. Now, when no voltage is applied to the diode, electrons from N-type material fill the gaps in the P-type material along the junction between the layers, forming a depletion zone. In the depletion zone, the semiconductor material is returned to its original insulating state. All of the gaps are filled, so there are no free electrons or empty spaces for electrons to carry charge. Now, light is a form of energy that can be released by an atom. Now, it is made of many small-like shells that have energy, which have momentum but no mass. Now, these are called photons and are most basic units of light. Now, photons are released as a result of moving electrons. Now, we're going to explain this to you using our visual representation. In the atom you can see in front of us, it has several shells. Now, to release energy, an atom has to move in a shell, and it would use energy if it moved out. Now, the more times it moves in, the greater the distance it moves in, the more energy it releases in the form of light. Now, many diodes are very inefficient at doing this, and therefore the light they release is only on infrared frequencies which the human eye can't see. However, in light-emitting diodes, which are very efficient at transfer of electrons from N-type materials to B-type materials, the gap which these electrons make from an outer shell to an inner shell is very great, releasing a frequency of light which is able to be seen by the human eye. Now, if you take a look behind me, you can see this diagram of a light-emitting diode. The semiconducting material, as in the diode, is positioned here. The electric current enters here and here, and you can see the light rays coming off. This particular LED is an example of red. Now, as mentioned before, the frequency given off by the orbitals, the electrons shifting their orbitals, is at such a frequency that it gives off red light. In other diodes, such as green and blue, the gap between the orbiting electrons' movement will be either smaller or greater to provide the right frequency. Well, that's all we have time for on this episode of Science Exploded. We'll see you again when we'll be exploding more science right before your eyes.